Hello everyone, this is the Chinese Mitten Crabs aquaponics project, and today we're going to talk about the STEM Arduino course for physics. First of all, have you ever used an Arduino board before? An Arduino board is a microchip controller board which can be used for programming and controlling circuits. It can be used to communicate with the outside world via different sensors, LEDs, motors, speakers, etc. There are many features on an Arduino board. First, it has an Atmega 328P chip. It can perform programs inserted and stored inside the chip itself. Programs can also be uploaded to the board by connecting the Arduino board to the computer via a USB and using a software called Arduino IDE. Other features of an Arduino board including there's lots of pins. We can plug various wires into these pins. This allows the Arduino board to connect to other devices. Two quite important pins that can be connected including the GND, which is the ground pin. It is important to complete the electrical circuit as it grounds the whole circuit, and therefore it acts as a negative terminal for your wire connections to the Arduino board during a complete circuit. Furthermore, it also provides power. The 3.3 volts or 5 volts ports provides two different voltages that can allow different components to run. The maximum current that can be drawn from these two pins are 40 milliamps, and therefore you cannot drive power-hungry devices with these two pins. On the top of the board, there are 14 digital pins, starting from pin 0 all the way to pin 13. They can act as either inputs or outputs. These pins can be connected to circuits to control them, including turning on and off, and can measure two stated circuits like buttons. On the bottom, there are A0 to A5. They are the analog input pins. They are useful for getting data from the physical environment with sensors or other components connected to them. Therefore, digital pins can only have two states, high or low, while analog input pins can have a lot of states. Actually, they have 255 states. To connect an Arduino, we usually make use of a breadboard. A breadboard is to make temporary electrical connections between components and testing circuits before soldering them permanently together. The holes on the columns at both sides of the Arduino board are vertically and electrically connected. There are wires running under the holes in the board to connect these holes together. The column next to the blue strip, or the holes labeled black, is negative, and the other to the red strip, which is labeled red, is positive. Some breadboards have the labels of negative and positive to indicate which column is positive or negative. The holes on the negative column are always connected to the ground. The holes on the positive column are connected to 3.3 volts or 5 volt pin. In the middle of the breadboard, there are two columns. The holes on each horizontal row are electronically connected. There are wires running beneath these holes, from A to E and F to J. But remember, the columns A and E and the column F to J is not connected. Electrical current from A to E holes will not carry to F to J holes. Now, let's go back to the Arduino Uno board. Let's first talk about lighting up an LED. In this diagram, we can see that the 5 volts pin is connected to the breadboard. On the breadboard, there is a resistor, and the current goes from the resistor into the LED light bulb, and then from the LED light bulb back to ground pin on the Arduino board. From this circuit, we can see there is a resistor. The resistor is important as this is used to limit the amount of electric current flowing through the LED and the prevention of the damage to the LED by passing too much current passing the LED. To understand why the resistor is important to prevent too much current passing through the LED, we have to know about Ohm's law. Ohm's law is helpful for us to decide which resistor we should use with the 5mm LED. Ohm's law states that voltage equals to current times resistance. In this setup, there is 2 volts supplied to the LED, and the maximum current we wish to pass through the LED is 20 milliamps. Therefore, by putting in the numbers into the Ohm's law equation, 2 volts equals to 20 milliamps times resistance. Then we convert to next step, which is 2 volts equals to 0.02 amps times resistance. By rearranging the subject, we find that the resistance will be equals to 100 ohms. Therefore, any resistor that is greater than 100 ohms will work in this situation. Now, we have a question. How can we know the amount of resistance that is in a resistor? After all, there are no numbers on the resistors. To understand the amount of resistance in each resistor, there are color codes. The color code on the resistors is to signify the value of the resistors. You can use the resistor color code calculator to decode the information contained in different combination of color bands. Here, we can see a table of different colors corresponding to different resistance. Furthermore, the colors also codes for the multiplier and the tolerance. The table might look confusing. Therefore, let's use a 5-band resistor as example. Here, we can see a resistor with 5 different colored bands. From left to right, we can see the colors are orange, red, brown, black, and then brown. So how does these colors translate to the resistance of this particular resistor? From left to right, according to the table, orange is number 1, red is number 2, brown is number 1, and the 4th band, which is black, is the multiplier, which is 1 ohms. Therefore, the resistance of this particular resistor is 321 or 321 times 1 ohm equals to 321 ohms. Then, what about the last band, the 5th band? The brown band on the far right. The 5th band represents the tolerance or the inherited error within this resistor. In this case, the band is brown, indicating that the tolerance is 1%. Therefore, meaning this resistor is 321 ohms with a 1% error. 1% of 321 is 3 ohms. Therefore, this resistor's resistance can range from 318 to 324 ohms. Now, when we look at a resistor, How does one know which side is left and which side is right? From this resistor, we can see there is a gap between the fourth and fifth band. Usually, the single out band separated by a gap indicates it is the fifth or the far right band. Therefore, by looking for the gap between the bands, we will know how to read the resistor's resistance from the colored bands. However, not all resistors are coded with 5 colored bands. Some resistors are only coded with 4 bands. That being said, even with a 4-band resistor, we can still use the same table to decode the resistance of that 4-band resistor. Here, as an example, we have a 4-band resistor. From left to right, the bands are gray, white, red, and green. Let's find out its resistor by using the table. Gray means 8, white means 9. The third band is red, meaning the multiplier is 100 ohms. That means this resistor has a resistance of 89 times 100 ohms, meaning this resistor has 8,900 ohms. The fourth and last band is green, meaning that this resistor has a tolerance of 0.5%. Therefore, as summary, this 4-band resistor has a resistance of 8,900 ohms plus or minus 0.5%. This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. Click on the tab to watch the next part of the video series.